So coming back to the question, as you have seen, when someone is running, it means that their tissues are respiring, especially the muscle tissues. And there you could expect that you want hemoglobin to release the oxygen to the tissues, basically the muscles. And that is why you would expect that after the exercise, you don't have a lot of oxygen being bound to the hemoglobin. Okay, that is what you would expect. Okay, so let's look at the questions. Oxygen saturation, we have already explained. It is an issue to do with the to the percentage of hemoglobin that is bound to hemoglobin. And then using the data, can you explain the oxygen delivery to the muscles and how it changes? Here, before the exercise, you could expect that you have more red blood cells carrying more oxygen to the tissues. So that is what you could expect. And that's why it is very high. After the exercise, you could expect that the person has rested enough and they have more time to breathe in and make sure that they have sufficient oxygen. And that's why there is no change in terms of arterial oxygen saturation before and after the race. Now, the difference comes in the venous oxygen saturation. Here, we are saying that while the person is running, or not even before running, now before the race, it is what we could expect, what could be expecting, that when you're resting, your blood is moving, and it is moving normally, right? Where your heart pumps the blood to deliver oxygen to the respiring tissues. Definitely when that blood returns back, it is not rich in oxygen because that oxygen has been picked by the tissues, and what returns back is blood that has less oxygen, and that is expected, that is at 70. But now when you run, the tissues become very efficient in picking this oxygen. That's why this oxygen actually reduces to 25%. That is what you can get in the venous. Remember talking about venous blood that returns to the heart. It is having less oxygen, especially after running, because much of it has been used. So that means that during the exercise, more oxygen is picked compared to if someone is not running. So that's the whole point there. So that is 1.2. And then hemoglobin, we are saying that hemoglobin has different affinities for oxygen depending on the concentration of oxygen. It has the extent to which it can pick oxygen is different depending on the oxygen concentration. When you have low oxygen concentration, hemoglobin will not want this oxygen. Instead, it will release it. And then when you have a lot of oxygen, hemoglobin will instead be wanting to pick it. So this picking is the loading, the release is the unloading. Okay? And then I suggest to you why hemoglobin releases more oxygen in active tissues such as muscles during respiration, during exercise. The whole point is about the same thing of when you have less oxygen concentration, oxygen is going to be released. If you have more oxygen concentration, oxygen will be picked. But in this case, about the race, when people are running, their tissues are respiring and they produce carbon dioxide. And usually hemoglobin, when there is high concentration of carbon dioxide, it will give up the oxygen and pick carbon dioxide. And that's why, in this case, we're saying that hemoglobin releases more carbon dioxide in active tissues because the active tissues are having carbon dioxide there. And that carbon dioxide is instead picked by the hemoglobin, and the oxygen is released. So that's that.